Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. We've been talking about systems for generating logic puzzles because you may want to have a logic puzzle in your game, but you may not want to have the same logic puzzle each time because then if a person is playing a game for the second time, and they already know the answer, then that puzzle, is no longer a puzzle for them. And in this video, I'd like to demonstrate another sort of more elaborate version of what I've been doing over the last couple of videos. So let's just look at the text first. This is the text that is always going to appear in exactly the same form every time you run this new program. You might notice it says logic 2 up here. I've created this one as a separate program because it's sort of, I thought it was different enough. So it says there are three beings, one is an angel, one a devil, and one an alien, but you don't know who is who. The angel only makes true statements, the devil only makes false statements, and the alien may make true or false statements. So that is the same as it has been in the previous couple of videos, but this bit is new. One of the beings holds a scepter. You must determine which being has the scepter. Note that you must determine the number of the being which has the scepter, not whether they are the angel, devil, or alien. In other words, in the previous program, you have to work out which being is the angel, which one's the devil, and which one's the alien. In this, you don't necessarily have to work that out. You may still, it may be ambiguous what the roles are, but it won't be ambiguous who has the scepter, or at least that's true if I've programmed it correctly and I haven't made any mistakes. So the answer is only has one aspect. It will only tell you who has the scepter. So let's go through an example. This one is just the first one that came up when I was on this computer. To be fair, this is a little bit longer than most of the runs that I've done, as in there's a few more statements, so it's a little bit more complicated, but let's have a look. I'll be working with pen and paper, so if you hear some pen and paper sort of noises off, that'll be what it is. So let's maybe start with what being 3 says. Being 3 says that being 1 is the alien, the angel does not have the scepter, and the alien does not have the scepter. So let's say that being 3 is the angel. If being 3 is the angel, and therefore everything they say is the truth, then being 1 is the alien, and being 2, by elimination, must be the devil. And being 3 also says the angel does not have the scepter. Well, that's okay, because sometimes these, like when a being says the angel does not have the scepter, they might be referring to themselves. They'll still say the angel does not have the scepter, because if they said I do not have the scepter, that would sort of give away that they were the angel. So being 3 claims that the angel does not have the scepter and the alien does not have the scepter. So if both of those things are true, then the devil has the scepter. So if being 3 is the angel, then being 1 is the alien, being 2 is the devil, and being 3 is the angel, and being 2 has the scepter. So now we can look at what being 1 not what being 1 says, because being 1 in this scenario would be the alien, and they can either lie or tell the truth. But we would need to look at what being 2 says and see if there's any problem there. Well, being 2 says I am the alien. Well, that's a lie if they're the devil, so that's fine. Being 3 has the scepter. That's a lie. Being 3 is the devil. That's a lie. And I am the angel. Well, those are all lies. So that's all compatible. But we didn't sort of prove that being 3 was the angel. We just assumed it. So let's see if there are other assumptions and see if we can rule them out. So let's say that being 1 is the angel, and then later on we'll assume that being 2 is the angel. So if being 1 is the angel, well, that can't be true because this being says, I am the devil. And actually only the alien can claim to be the devil. The angel won't say it because it would be a lie, and the devil won't say it because it would be true. So actually we know that number 1 can't be the angel. The only other possibility is that they are the alien. Number 2 is the angel, and number 3 is the devil. But being 2 says, I am the alien. So being 2 can't be the angel either. So actually we know that being 3 must be the angel. So the thing that we started off, so we got lucky. We started off by assuming that being 3 was the angel, and in fact, it seems like they must be the angel. So in that case, being 2 should have the scepter. So if we click, and it says being 2 has the scepter, you'll see that it doesn't say what the different roles are, because sometimes it won't be certain what the roles are. We're only trying to find out who has the scepter. So there's an example of how the puzzle works. Adding another element, that element of the scepter, doesn't necessarily make it more complicated. I think it probably did in that case, but it doesn't always make the puzzle more difficult anyway. It's just a sort of another option. But let's very quickly have a look at the code. So we'll zip in here. It's very, very similar to the original one. I did it as a separate program because I wanted to preserve the code that lets you do the simpler puzzles. Simpler in the sense of simpler to program and stuff, not necessarily easier to solve. But so you'll see that it's very similar to the previous 2 videos if you've seen them. So the first thing I always do, I don't always think to mention this when I'm going through the code, but the first thing that I do when I'm starting a story is, firstly, I always go to the JavaScript, and I always put this line of code, capital C ONFIG dot passages, PASSAGES dot NOBR equals true, semicolon. What that does is it tells the computer if there's a line break like this, that's just for layout. All of these line breaks are not telling the computer to print a line break on the screen. If you don't specify that, by default it does assume that every line break is telling it to make a line break on the screen. So it's very, very difficult to have good layout, because good layout is sort of clear layout, and clear layout is layout that separates things a lot of the time anyway. So I always put that little bit of JavaScript in there. And the other thing is I always go to details, and I always choose the latest version of Sugarcube, because by default, I think the default is that it's always Harlow, which is quite different. Like it's almost a different language. The JavaScript and the HTML is the same, but the Twine specific commands, most or all of them are different. So I always go to details and make sure it's Sugarcube, and always add that bit of JavaScript. So let's go quickly through the actual program. So it's very similar to in the previous 2 videos. We have the array with the names of the roles, angel, devil, and alien. We have B. Some of the letters have changed, but their function is the same. This is one of them. So BZ is what role being Z has. So if B2 is 3, then being 2 is role 3, which is to say the alien. Then we have S, which being is carrying the scepter. We have L, which is a 3-dimensional array, and LZYX, refers to the situation in which being Z is the angel, being Y is the devil, and being X holds the scepter, which of course means that for it to be a real situation, Z and Y must be different, because the way the puzzle is stated to be, the same being can't be both angel and devil. But Z can be the same as X and Y can be the same as X, because of course the angel can have the scepter or the devil can have the scepter. And for any given slot in that three-dimensional array, 1 means this situation is still hasn't been ruled out given the statements which have been made so far, and 0 means yes, actually it has been ruled out by the statements that have been made so far. So we set up L to always have the value of either 1 or 0. Essentially, if Z is equal to Y, then we initially set it to 0, because in real life, not in real life, but in the puzzle, that the puzzle can never be one where the angel and devil are the same being. And for any other situation, we set it to 1 to start with. Then we have T, which is, as you can see here, TZ0. So it's a two-dimensional array. TZ0 is how many statements being Z makes, and TZY, where Y is a number over 0, is the Yth statement that being Z makes. So that means that TZ0 will be a number, and TZ1, for example, on 2 and 3 and 4 and up to however many statements that being makes, will all be text. So we have the one array, but it's got a mixture of text and numbers in it. And that's fine. In some languages, that would be a huge problem. Each variable has to be a particular type. But in Twine, it's fine. We can mix them freely. And we set them up. Of course, TZ0 is initially 0 because we don't have any statements. And then I've just got a little note about temporary variables that I always have at the end. So then we assign the roles. So we choose two random numbers between 1 and 3. If they're equal, we include assign roles, and because this page is called assign roles, that means we just try again, basically. And then we set BZ, and remembering B is the array that keeps track of who is angel, who is devil, and who is alien. Being Z is equal to 1, which is the angel. Being Y is equal to 2, which is the devil. And being 6 minus Z minus Y is equal to 3, which is the alien. So, for example, let's say Z is 1 and Y is 2, or vice versa. 6 minus Z minus Y will be equal to 3. Well, that's right, because if that's 1 and that's 2, we want the other slot is slot 3. Or let's say Z is 1 and Y is 3, then 6 minus Z minus Y will be 2, which is the missing one. And the same is if it's 2 and 3, then the other one will be 1. So that formula always gives you the other number from 1 to 3. Then we go to add statements, which is fairly simple in itself. We choose a being, we generate a statement that being makes, and we add it to the array of their statements. We eliminate all the possibilities that are ruled out by that statement, and then we check whether we can now present the puzzle. So obviously most of the code is within these, actually specifically within these two includes. So let's just do them in order. Generate statement. So as you can see here, there are 6 sort of classes of statements. So there's this being has this role, this being does not have this role, this being has the scepter, this being does not have the scepter, or the being with this role has the scepter, or the being with this role does not have the scepter. And I wanted them to not be equally likely. I wanted statements about the scepter to be 50% of the time, and statements about beings having roles to be half the time. And the way I did this was we set a random number from 1 to 8, and then if we get over 6, we take 6 away. So 7 becomes 1 and 8 becomes 2. So 1 and 2 are twice as likely as 3, 4, 5 and 6 because 1 and 2 are the statements about the roles, and I wanted to increase the chances of those two so that those statements will happen roughly half the time or half the time on average. Then we generate the being about whom the claim is made, the role which is claimed for a being, which is only used in I think I might have made a, sorry. Oh yeah, no, I haven't made a mistake. The role which is claimed for being X, which is only used in these two statements. Now, this is quite a long bit of code, and I'm not going to go, as you can see, it sort of keeps going because each class of statement works slightly differently. But I'm not going to go through each one. I'll just go through one, and then you can, of course, as with everything else, you can download the code and have a look at it. But so what we do in this bit of code is we generate the text, which will be presented to the player, which is the statement, and then we generate the truth value of the statement. We determine whether the statement is true or false, because that's what we need to see whether it's a statement that can be made, because the angels only tell the truth and devils only lie is the sort of core of the way the puzzle works. So let's look at we'll look at one I haven't done yet. In other words, one of the new ones. Let's say that the type of question is going to be that B is type 3, which is being X has the scepter. Well, we know that S is the value which stores which being has the scepter. So let's look at 3. Let's look at the case where Y equals 3. If Y equals 3, the claim is that being X is the scepter. So therefore, if Z is equal to X, in other words, if the being that's making the statement is the same as the being that is the subject of the claim, then U, the text for the statement, is I have the scepter, and if not, it's being X has the scepter. And if S, the variable that is who's got the scepter, is equal to being X, the one that is claimed to have the scepter, well, that's a true statement, and then therefore we set V equal to 1. And if not, it's a false statement, and we set V equal to 0. So let's do another one. Let's say the being with role W has the scepter. That's number 5. I'll do this one and then we'll move on. If Y equals 5, the claim is that the being with role W has the scepter. In this case, there's no if when they're setting the text. It's always the angel has the scepter, or the whatever it may be. Coming off this array here, it's always going to be the angel has the scepter, or the devil has the scepter, or the alien has the scepter. Let's go back to where we were. Sorry, where's the 5? There we go. Because the beings can talk about themselves in the third person. In fact, they have to talk about themselves in the third person when they're talking about the angel has the scepter, because if they didn't, that would give away, if they said, I have the scepter and I am the angel, well, that gives you sort of 2 bits of information and not 1, basically, and it makes it a bit complicated to code and also easy to solve, and so that's not what I did. So we have the text, which is the angel has the scepter, or the devil, or whatever, and if the role, remember that B is which it's like BX is the role that the Xth being has. So if the Sth being, in other words, if $B square bracket $S n square bracket is equal to W, in other words, if the being that has the scepter has the role that this claim says they have, then V equals 1, i.e. it's a true statement. And if they don't, then V equals 0. I won't go through the other four. You can sort of see how it works. And then at the end, we have this. If V equals 1, in other words, if we've assessed that the claim that's made is true, and BZ is equal to 2, in other words, the being making the claim is the devil, well, we have a problem because that's the devil making a true claim. And if that's the case, we include generate statement. In other words, we start all over again, which does waste the code where we generate the text, but that was the easiest way to code it, was by doing it that way. So that's a sort of problem I was prepared to have, because the other way we do it is we'd have one bit of code where we generate the truth value, and then we'd have to have another bit of code with the same if y equals 5, else, etc. We'd have to have another branching bit of code afterwards where we generate the text. So it was easy to generate them all at once with the possibility that we waste one of them. Else if V is equal to 0 and BZ equals 1, in other words, if the claim is false, but the being making the claim is the angel, well, that's a problem for the same reason, and so we do the same thing. We generate the statement. Otherwise, yes, this is fine. So if the claim is true and it's the angel, if the claim is false and it's the devil, or if the being making the claim is the alien who can say anything, then we increase TZ0 by 1. We add 1 to the number of statements that being Z has made, and we set the most recent statement of being Z to be equal to U, which is the string that is the statement. So something like being 3 does not have the scepter in this case, or I do not have the scepter, or whatever it may be. So that's generate statement. Then we eliminate the statements. We eliminate the situations that can't be true based on that statement having been made. Once again, I won't go through every possibility. Let's say, let's look at, this is a quite long bit of code, which is branching based on y. So we say if y equals 1, then do everything here. Otherwise, if y equals 2, do everything here. Otherwise, if y equals 3, otherwise, etc. So I'll just show you one or two possibilities. So let's look at y equals 3. Y equals 3 is being Z is claiming that being X has the scepter. So what do we need to eliminate? Well, we eliminate all possibilities in which Z is the angel and X doesn't have the scepter, because then that would be the angel making a false statement. And I'll come back to the code. And we eliminate all possibilities in which Z is the devil and X does have the scepter, because then the devil would have said something true. So let's have a look at eliminating the possibilities where Z is the angel and X doesn't have the scepter. We have Z1 and Y1, and they are, I don't think I've indented those quite, oh, maybe I have. I thought I hadn't indented them quite correctly, but anyway. So Z1 goes from 1 to 3, Y1 goes from 1 to 3, so we have every combination of these two variables being from 1 to 3. We look at the variables where Y1 does not equal X, and we get rid of the situation where Z is the angel, because remember L has 3 dimensions. The first dimension is who's the angel, the second dimension is who's the devil, and the third dimension is who's got the scepter. So we get rid of every possibility where Z, the claimant, is the angel, and where X doesn't have the scepter. So because we're only doing this if Y1 does not equal X. So for example, if if being 1 claimed that being 3 had the scepter, then we would get rid of, let's say, 1, 2, 1, 2, 1, because then being X would not have the scepter, and I can't remember what I said. Sorry, I forgot it. Let's say if X is 1, then we'd activate this when Y1 was equal to 2 or 3, because when Y1 is equal to 2 or 3, that means that X doesn't have the scepter. In other words, the value for the being that has the scepter is something other than X. So any situation where Z is the angel and Y1 does not equal the scepter, does not equal X, in other words, where X isn't the being with the scepter. And then we eliminate all possibilities in which Z is the devil and X does have the scepter. So we have Z1, which goes from 1 to 3, and we get rid of anything from 1 to 3 can be the angel, Z is the devil, and X is the being with the scepter. We set all of those to 0. And then we have similar code for all 8 different possibilities. And so I won't go through every one of those. Again, you can look at that if you want to download the code, and you might even find a mistake. Every one of them had to be done sort of by hand. I did notice I'd made some mistakes in the previous because I was adding, this is basically like the old program but with extra options, and when I was going through the options that were the same as in the previous program, I did find a couple of mistakes. So it's quite possible that I've sort of misthought about how this works. But it does seem to work, at least in the sense that when I've run the program, the answer that I sort of reasoned my way to has always turned out to be the answer that the game actually gives. So that suggests that it is at least mostly correct. So anyway, we've eliminated some stuff from L, and now we have to check where we're at. Are we ready to display everything, or do we have to generate another statement? Well, let's have a look at check. This is it's relatively relatively short. I just realised I put that comment in the wrong place. That comment should be probably at the top of that. But anyway, so we want to see how many beings could still be the one with the scepter, because the criteria for stopping is based on the statements that have been made so far. There's only one being that could have the scepter. So we set Z to 0, and we're going to say Z is now the number of beings who could have the scepter based on what's in the L array. And then we go from 1 to 3. We have a for loop with Y. Y is the being that we're looking at the moment. And we're going to go, of course, through all 3 beings. So for each of those beings, we set X to 0. X is going to be set to 1 if we find any case where being Y could have the scepter. And then we have W is 1 to 3 and U is 1 to 3. And then we look at L. And if L, W, U, Y is equal to 1, then X equals 1. So what that means is W can be any number from 1 to 3. U can be any number from 1 to 3. And then Y is the being that we're looking at. And because the third dimension of the array L is who's got the scepter, if this is equal to 1, then that means there is some situation where Y has the scepter. Now, you might say, well, if W is equal to U, wouldn't that be an impossible situation and therefore it shouldn't count? Well, that's true, but situations where the first 2 numbers are the same are set to 0 at the beginning of the program anyway. That's what this bit of code does. So they're never going to give a 1 anyway. So we don't need to sort of filter them out here because they're already set to 0 anyway. So if we get a situation where we've got any possible angel, any possible devil, and the being that we're currently looking at as the one with the scepter, then we set X equal to 1. And then at the end of that for loop, we set z equal to z plus x. So what that means is we've looked at being 1. If x is equal to 1, then set z equal to 1 because z starts at 0. Or if x is equal to 0, in other words, we haven't found any situation where being 1 can be the holder of the scepter, then keep z at 0. And then when we look at being 2, at the end of looking at being 2, we'll either add 1 to z or we won't, depending on whether being 2 can. And then finally, we'll add 1 to z if being 3 can be holding the scepter. And then we look, once we've done all that, we look at z. And if z is equal to 1, then we know that we're ready. We go to give statements. And if anything else is the case, then we go to add statements. Now, you might say, well, hang on, what if z is 0? Then you're going to go back to add statements, and you'll be caught in an error because it'll keep adding statements forever, and you'll eventually run out of memory. Well, there's no way for it. There shouldn't be any way for it to go to 0, because 0 would mean no one can have the scepter, and that's not a situation that can be given the parameters of the puzzle. And so, if the logic that is in all of the possible situations is correct, it'll never end up eliminating the possibility of every being having the scepter. If it does that, then that indicates that there's something wrong with at least one of the procedures for changing the values in the L array. So, if we're finished, we go to usually, of course, we won't be finished. So we go back to add statements and we generate another statement. Or when we're finished, we'll go to give statements. Now this works exactly the same as the previous program. So except for the fact that there's this extra text. So I won't go through it in great detail, except to say that it's an HTML table, and you saw what it looks like. It has being 1, being 2, and being 3 in bold in the left-hand column, and then in the right-hand column it has every statement that they make that is not a duplicate. In other words, if it generates the same statement twice or 3 times, it'll only say it once, because saying it the second or third time doesn't sort of add anything to the puzzle. And then at the bottom there's the option to click to get the answer once you've worked it out, and of course, this is very simple. It just says being S has the scepter and gives you the answer. So that is the sort of more in-depth version of this particular type of logic puzzle, which is sometimes called the Knights and Knaves puzzle. So I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.